Hi guys, in this problem I really kind of wanted to help you picture what was going on, and I was kind of having fun solving this problem, so I thought I would help you guys out by picturing it a little bit better. So I put together a little animation showing how the cars are lining up. So it says a speeder passes a parked police car at 30 meters per second. Police car starts from rest with a uniform acceleration of 2.44 meters per second. So you're thinking about cars racing past each other. You got this one that passes the police car, and then the police car starts catching up with it. How much time passes before the speeder is overtaken by the police car? So we need to find time. We have our initial velocity, and then we have an acceleration, but you guys are I think you're getting a little confused on how we should apply that acceleration. Let me show you this, and then it'll make more sense. So I put together a little animation here, kind of giving you an idea of what's going on. And let me start this animation so you can see. So you got the speeder in the red car here that passes the police car. As it passes the police car takes off and starts accelerating at a uniform acceleration of 2.44 meters per second. Alright, so this is a perspective problem. So you have to think about it in a different perspective. You guys are thinking about everything going on here. You're thinking about the road, you're thinking about the two cars. So the road is not a part of this question. So let me see if I can get rid of that for you guys. And then I'm going to turn this up on end here so you can see it at a different angle. Let me go back to my previous screen, and I'll start this again from 0. And let's see if you guys can start picturing this from a different angle if I run it at like this, run the simulation a little like this. So this is the point we're worried about. When is the police car starting to take off? But if you notice, if we look at it from this perspective, let me keep zooming out while this is going. If you're looking at it from this perspective, it's a lot like if you tossed a ball up in the air with an initial velocity of a certain amount, and then that ball came back down, right? So if you're thinking about it from this angle, it looks like a problem now you guys are familiar with. So it starts off right here, the car passes the police car, and then the police car is going at this point, and it starts catching up with this other car. But you guys are thinking about it as if the road is even a factor here, and it's not. So how do we write this up? So let me go ahead and start that for you. So let's write up what we know. So the velocity of the speeder, the initial velocity, is 30 meters per second when it passes the police car, right? And then you have, you want to know when the police car catches the speeder, so that you want to know their distance, or we know their distance when the police car catches them. So when the police car catches the speeder, it's going to be 0 meters, right? Because they're at the same level at that point. And then we also know another value, which is the acceleration. But when we're looking at the acceleration from the speeder's perspective, that's going to act kind of like a deceleration, which I showed you in that image. It looks like the speeder goes up, right? Goes up and then comes back down. But from the example, you know that the police car is actually moving. But we're just taking it from the police car's perspective or the speeder's perspective, depending on what you're looking from. So the acceleration is negative 2.44 meters per second squared. Alright, which I got wrong earlier. I said that wrong earlier. That's okay. And then we're looking for the time it takes for them to catch up with each other at that moment. So we're going to use our displacement equation we used in the free fall examples there. So you go velocity initial times time plus 1/2 acceleration times time squared. So we're going to use that one right there to catch up with this. So our change in x is 0. Our initial velocity is 30 t, and then we're going to do 1/2 times acceleration which we can probably do that in our head. So that would be negative 1.22, right? 1.22, and then t squared here. Factor out the t, and you end up with negative 1.22 t plus 30 times t. Alright, and we're asking when that quadratic formula equals 0. Well, of course it equals 0 when t equals 0, because anything times 0 is itself, or is 0. Not itself. Okay, and then when does this part equal 0? So let's go ahead and solve that. 0 equals negative 1.22t plus 30. Subtract 30 from both sides. And you would get negative 30 over here equals negative 1.22t. Divide both sides by 1.22, or negative 1.22. And you end up with t equals 24.6 seconds. So it's going to be 24.6 seconds, and then that's 0 seconds. So when the car initially passes the police vehicle at 0 seconds, and then this is when it actually catches up, when the police car actually catches up to it. So that's the answer for part A, and that's how that works. Now we're going to use this time, which I think you guys can do, use this time and then multiply that times the rate in order to get the distance that the speeder travels. So we have our rate here, and then we're just going to multiply this times this in order to get our displacement of the vehicle here, or the speeder. And that's it. That's it for that question, guys. I hope you learned a lot, and I'll see you in the next one for the next question.